Okay. Of course, now I can't see the problem statement. How many pole machine was it? How many pole machine was it? 8 poles? So, and F is 60 hertz. So NS equals 120. And the 120 comes from the fact that we have, it's 2 over number of poles, which is 8. And then we have 60 to convert from seconds to minutes. And times the frequency, 60 hertz. $120 divided by 8 times 60. So we get 900 RPM. What was the speed of the motor? 845. So slip is 900 minus 840 over 900. That's NS minus NR over NS. Any questions on that? So parentheses 900 minus 845 divided by 900. See, so that's not 6%, right? That's 0.06111 repeating. Okay. Store alpha S. If we look at the percent error, though, alpha S minus 0.06 over alpha S times 100 to get to percent. It's only 1.8% off, right? But if you use 6, you got the totally wrong answer for the third problem, right? If you use just 6 instead of 6, 1, 1, 1, 1, 1, 1. So I had to tighten up the tolerances because people thought they were getting the right answer for the first problem, and they weren't. Let's just verify. There's a hotkey. I wish I could remember what it was. Control S. No. So I'll just stop share, and I'll go back to this guy. Okay, so let's try 0.06. Check. There you go. Okay. Okay, so for the second problem, it's the same motor, 8 pole, 10 horsepower, 3 phase. Stator to turns ratio, like I said, a lot of times that's just gonna be one, but for the homework problem, I wanted to include all the possible variables. So that's why I have the off unity, turns ratio. Determine the voltage induced on the rotor for phase, per phase. Okay, so okay, so first of all, we have to figure out what the block rotor voltage is. So how much voltage is on the primary? How much voltage is on the stator of the motor? 480 or 460? 460. So V line to line is 460. At the service central entrance panel, it would be 480. At the motor itself, it's 460. So if we want V phase, we have to take 460 and divide it by the square root of 3. Okay. So that'll give us a phase voltage. 460 divided by square root of 3. 265. 265.58 volts. I'm going to keep that whole thing in my calculator though. Now if I want to get the block rotor voltage, V block rotor, what do I need to do? I need to multiply by the turns ratio, right? So we got V phase times 0.5 over 1. Does everyone see how I got that? Okay, so times 0.5. So that's 132. 132.79 volts. Okay, am I done? No. So V2, the voltage on the rotor is going to be slip times V block rotor. So times, and I stored it as S, so that's great. So S is right there. Turn on the light so you can see what I'm doing. And there you go. 8.11. And again, I decreased the tolerance. So we got to make sure we get enough decibels here. 1149.78. So why don't we do 979? That's enough digits for sure, right? There's no way we're going to have problems with that. 4979. Yeah. Okay. Again, that mouse doesn't work, but this mouse does. Okay, so let's check her out and see if we get it. And again, what kind of values did you guys have that just put in the 6? Wasn't the same, right? So.
I got pretty close to that, but it was wrong.
It was still wrong, eh?
Yeah. I didn't go that far in decimal place though.
Yeah. 4979. Like I said, people were putting in 6, and some of them were getting, it said correct for this one. others weren't. Oh, got to put a V in there. There you go. Okay. And so that was number 2. Number 3, we needed to know what the induced frequency is. So the frequency on 1, oh, gotta switch over. So the frequency on 1 is 60 hertz. The frequency on 2 would be slip times F1. So we take 60 times alpha S. There you go. And we get 3.666 repeating hertz, right? Any questions? Okay. Stop share. Share screen. .66666 HC. Check. Yay! On to the next page. Okay, everybody with me so far? Okay, so now we've got a whole bunch of numbers. R1 is equal to 1.21. X1 is equal to 3.10. R2 prime is equal to 742. X2 prime is equal to 241 ohms. Gesundheit, XM, 65.6 ohms, 65.6 ohms. And let's see what else we got. Slip equals 4%. And P mechanical loss is 815. Okay. I think that's everything. Oh, 460, 60 hertz. Oh, this is only 6 pole. 6 pole. F equals 60 hertz. Okay. So the first thing we need to do is determine the speed, motor speed and RPM and radians per second. Okay. So new share? Oh, Alt-Shift-S. Alt-Shift-S. What happens there? Oh, okay, Alt-Shift-S, that's the way to go. Okay, so those are all our numbers. We got to figure out what the speed is. So what's the first thing we have to figure out? Let's figure out what the synchronous speed is, right? So what's the formula for synchronous speed? So this is number 4. NS equals 120 divided by number of poles, which in this case is 6, and the frequency is 60 hertz. So what do we get there? 1200. We can by inspection, right? Beautiful. Okay, so we got 1200 by inspection. So, and then if we want to get the rotor speed, it's just 1 minus the slip times the synchronous speed. And you can solve that for using algebra, right? From the, yeah, okay. So 1 minus 4% is 0.04, like that, times 1200, like that. So 1200 times 1 minus 0.04. 1152. Okay. Now, we could either solve for omega s and do the same thing, or just convert this to radians per second. Which way do you guys want to go?
Convert it.
Convert it? Convert it? Okay. Okay. So we've got revolutions. So this is 1152 revolutions per minute times 2 pi radians in 1 revolution times, let's see, what do we got here? 1 minute over 60 seconds. Looks good? Tastes great, less filling? Okay. Times 2 pi divided by 60. $120.64 radians per second. Okay.
That's right.
Yes.
And that's what you prefer us to solve it in radians per second, or?
Well, I'll ask you for it in RPM, but then there'll be certain questions on the test. For example, the torque or one of those calculations that it will need to be in radians. Okay. So you have to know both. Okay. So Alt Shift S. Oh. Really doesn't save that much, does it?
Does switch camera to top left corner?
What?
Does switch camera to top left?
Yeah, but I think that's just this. Yeah, just that. It's just that. It's nothing, not much to write home about. Okay. So we got 1152. Oh, look at that. First one on the list there. Whee! Now you get 3 chances at this, so, you know. Oh, my answer is correct. Okay. Determine the magnitude of the motor current. Alt Shift S, is that it? No. Control Shift S, no. Alt S. Oh, stop share is Alt S. Oh, but it didn't work, so there you go. Share screen. think Dr. Marlar came up with all the hotkeys, so I should look at his email again and figure out what he wants. Okay. So, here's the circuit model that we have. Now, I can combine those two resistances into one, like it was originally. So our circuit model could look like this when we're just looking for input current. Does that make sense? So I could just have this one variable resistor instead of having a fixed resistor and a variable resistor in series. And this is going to be R1, X1, XM, R2 prime over S, X2. Okay? And the voltage is going to be V phase. Okay. So, I1 is going to equal 460 divided by the square root of 3. Let's see, what was R1? Oh, right here. Okay, I got you. R1 was 1.21. Yep. Plus J 3.10 plus J 65.6 times 0.742 over 0.04 plus J 2.41 J 65.6 plus 742 divided by 0.04 plus J 2.41. Does everyone see where I got all those numbers from? Hopefully. Okay. So let's try plugging it into the calculator. Hopefully I get the right answer this time. 460 divided by square root of 3. Now, Lewis, you didn't send me any notes, so I'm assuming that the answers that I have now are correct.
Okay. I wasn't able to solve until yesterday, because my calculator kept giving me different numbers.
Oh, that's no fun. Okay.
I tried to solve them.
Okay. Okay. So 460 divided by the square root of 3. And I'm just going to put a lot of parentheses in just so there's no question about things. Okay. 1.21 plus 3.10 I. Yeah.
We put 1.20.
Oh, see? Got to keep a close eye on me. Plus, yeah, we're multiplying two things together, so this should be fine. 65.6 I times parentheses 0.742 divided by 0.04 plus 2.41 I divided by parentheses, 65.6i plus back up a little bit, 0.742 divided by 0.04 plus 2.41 I, parentheses, maybe another one parentheses just for good luck. So 133707. Save changes. Hopefully people are seeing the different things. So I'm going to save that, store alpha I. Okay, good. And now I'm going to calculate the stator copper losses. So this is number 6. P stator copper losses is equal to 3 times the magnitude of I1 squared times R1. And R1 was, so that's going to be 3 times the magnitude of I1 shift alpha I squared times 1.21. Yes. 648,957. So 9. Well, I'll put the whole thing in. But then you just should have to just enter in 5 significant digits. That should be enough. 658, 95, 79. Okay.
Wait, can you show us how to do the absolute value on that calculator?
Yeah, it's this F2 key right here, ABS.
Okay.
Oh, let's see. So that's the complex number. ABS is, and that's the same on both the TIs and the Casios.
Yeah.
ABS is the absolute value.
Okay.
And if you take the absolute value of a complex number, you just get the magnitude.
Okay.
Okay. Okay.
So that the magnitude is the 13.37.
Yes.
Okay.
Yes. But this way, I don't lose any accuracy.
Okay, and then can you also show us how to store on this calculator, how to store an answer?
How do you store? It's this arrow button right here.
Okay.
And then I use an alpha, and then I have A through Z.
Okay.
Okay. So I have 26 places to store things. So the correct answer, which is probably the answer that we had before, 7, 9. Is that right? 9, 5, 7, 9. Okay.
On that rate,
Yeah.
I don't know if I'm plugging in this I don't know if I'm plugging this into my calculator correctly, but I'm getting 648.88.
Did you use the full resolution of your value, or did you round?
I round, oh, okay.
Yeah, so you're always gonna get errors when you round. So that's why you should store your values or use second answer. Okay?
Okay. Thank you.
Yeah, you're always gonna introduce error when you round. And like I said, that 6% instead of 6.111%, that was enough so that people were getting the answer wrong on the third part of the problem.
Okay.
They got it right on the first one because the error bound was so loose, but so save changes. I keep wanting to use the pad, but it's not working. There's probably a key that I hit, isn't there? That turned off the mouse, but anyway, okay. We do that, go back to grades. And this is the highest grade, so if you had it before, you shouldn't have to redo the problems because it regrades every attempt. Okay, so let's go back to the homework problem.
You might want to just have a second tab open that you can just hit refresh grades on.
What?
You might want to just have a second tab for refreshing the grades, so that way you don't need to keep.
Educat doesn't like that.
Oh. Okay.
It'll kick you out, yeah.
Oh.
I've even tried using different web browsers.
You get timed out.
Oh.
Yeah. It's in some ways a user hostile program. You should see the formulas. When I do formulas, the formulas are super long. Okay, so again, but now let's try it with just five decimals and see if it's okay, or 5 significant digits. So 5 significant digits would be 6, 4, 8, and I won't do that. And then 9, 6 would be 6, 4, 8, 9, 6 would be 5 significant. Let's see if that's enough. So 5 significant digits would be enough. Okay, with the error bond that I have. So you don't have to put all those numbers in there. Okay, air gap power, number 7. P air gap. Oh, we're almost out of time. But the air gap power is going to be 3 times the magnitude of I2 squared times R2 over slip. R2 prime over slip. So we have to figure out what I2 prime is. And that, again, is going to be the impedance on this parallel branch. So going back up here, I2 prime is right there, okay? So we're going to use current divider to come up with this current. So we'll take this impedance over the sum of the impedances times I1.
I wasn't like rounding the whole number, and every
Okay.
time I